This video goes through several examples involving a home mortgage, a car leasing situation, and we'll start with saving for a college education for one's child. Financially planning for a child's higher education is a common situation and best to be started early because you only have 18 years or so to gather the needed funds. It is a two-step process. First, decide how large a fund is needed, and then secondly, determine the payments required each month to attain this fund. For the first step, let's assume that we're going to withdraw $15,000 semi-annually. So that's a total of 8 times that, since a semi-annual of $120,000. That will be done over for 8 payments, since it's semi-annual, over 4 years. We're assuming they'll be done in 4 years. We're going to assume that payments are exactly every 6 months. Make it a little bit simpler. And we're also going to use beginning of year payments, which is different we've been doing in the past. We always had end of year, but you need the money. The universities want your money at the start of the semester, so it's a beginning of period withdrawals. And we do that with a type code, which we'll see in a minute. So how much money we're going to need? We're going to go for 8 years. It's in a fund that pays 5% NAR monthly. We need to find the present value of these 8 payments of $15,000 to find what we'll need at the start of these 4 years or the 8 semi-annual periods. What is the beginning balance we need? And so since this is semi-annual, we need to get to a semi-annual periodic interest rate, PIR. So we have a change in rate required here. So we go from our payment rate of 5% NAR monthly. We have to go up to the EAR, which is, use the effect statement, it's 5.12%. Then we go down the branch to the semi-annual and get the NAR semi-annual using the nominal function, which comes out at 5.05% approximately. And then we can divide that by 2, so it's be twice a year, and you end up at 2.53%. So the PIR we need is 2.53%. And with that, we can find out how much we need at the beginning of the 8 semesters of college. We start with a rate B8, 2.53%. B4 has 8 semi-annual periods. B2, I'm sorry, is the payment, $15,000 we're going to receive, so it's positive. It's going to be 0 at the end when we've taken all the money out and paid for the education, and then here's that type code of 1 sitting out here at the end. That says beginning of period withdrawals. So with that, we find we need $110,146. So we don't need 120, we only need 110. We save $10,000, we earn $10,000 of interest during the 4 years. 3.5 years, so with 3.5 years in, you may take the last amount out. So that's our goal, $110,146. How do we get there? Well, we're going to put in a monthly payment, so we're back to monthly. We can use a monthly PIR, which is the NAR monthly, 5% divided by 12. We're going to say we have 18 years. We're doing this right at the child is born. At the end of the first year, put in the first month, and we're going to do this for 18 times 12 or 216 months. So we find out what payment is required. B11 is the rate, which is the 417. B13 is 16 periods. We're going to start with 0, and we want to end up with B9 or the $110,146. We will receive that at the end of this. And the payment then is $315.42. Fairly straightforward, but it does require 2 steps, which sometimes causes some concern. In this case, we find out first how much is needed, and then go this way. You could sometimes go the other way and say, we're going to put this much in, what do we have, and then When we spend it in retirement, how much can we take out a month and go the other direction? Many problems with finance are two steps like this. Next, we'll look at a mortgage or home loan situation. Consider the Chipettas who are looking at a $500,000 home and received the following information concerning three alternatives. The alternatives differ on the nominal rate with monthly compounding and amount of down payment. The third alternative is only for 5 years, and a payment at the end of year 5 called a balloon payment is due. You can see this in the data. The first one all have a $500,000 home value. The down payment percent is 10% on loan X, 20% on Y, and 20% on Z. With a 10% down, the down payment would be 10% of 500,000 or 50,000. So the loan amount is the difference. And the loan amount is what the bank loans you, so that's what the interest is based on in the monthly payments. The NAR is 5% for that loan with 10% down. If you put 20% down, you can get 4%. And if you do this balloon payment where you pay it off in 5 years, a little bit less risk for the bank, so they will give you a rate of 3.8%. The periodic interest rate, the monthly one, is simply the NAR divided by 12 in each case. Each one is divided by 12, a little bit smaller. The first two loans have 360 months, that's 30 years, 12 months is 360. The last one is a 5-year loan, so it only has 60 months. But it also has a balloon payment of $360,000 at the end of 5 years. So with this, the other two will be paid in full. With this, we can find the payment. We've done this quite a few times. This should be coming fairly normal to you. The rate C7 is a PAIR. C8 is the number of periods, 360. C5 is the present value, just 450. It's a loan value. And C10 is 0. That's the balance on the loan at the end. The future value is 0. And with that, you did 2,415.70. Going through exactly the same thing, only a little bit different numbers. 400,000 is the loan value, 4% interest, a little bit lower. And otherwise it's the same. And if you put 20% down, your down payment or your monthly payments will be $1,909. It's gone down about $500 a month if you have the 20% down. On this one here, you put $360,000, you pay them at the end of 5 years, you sell the house or whatever, refinance. You have adjustable rate mortgages, ARMs, that there's various kinds. Some of them change the rate every 5 years, some do every 1 year, and so forth. You could look at this as being a 5-year adjustable rate mortgage, and so in 5 years you either would get a new rate or you have to refinance or something. Kind of in that order. The payments done the same way, except that the future value in 10 is 360. E10 now has a 360 in it. And with that, the payment is $1,873. You're going to pay down $140,000 over 5 years is what it amounts to. But you were getting the $400,000, so you're not just borrowing $160. You're borrowing that, but you're paying it back. And that is the way you really compare loans in large part, especially if your interest is in the payment size. To look at this a little more depth, let's look at this first mortgage. Loan X was $450,000, 5% or 0.417 PIR, 30 years, 360, and a monthly payment of $2,417.70. Question might be, what is the balance on the loan after 5 years? Well, there's two ways to determine that. It's either the future value of your 60 payments, 5 years or 60 monthly payments, and you do that with the future value. C19, the rate, PIR, C23 is 60 months, C22, the present payment, is the $2,415.70, and the present value is the loan which was started at $450. And with that, you see that the future value of that loan after 5 years is $413,229. To pay it off, you have to pay them $413,229. It has come down about from $450, $37,000 in the first 5 years. It goes down very slowly at the start and gradually accelerates as you have less balance to pay interest on. Payment stays the same, so more goes towards the principal than interest as you progress with the loan. You can also find the same number by taking the present value of the remaining payments. If there's 5 years, 60 are passed, then you have 300 remaining. And the present value, C24, is 300 payments. And that says that, essentially, this is a little confusing, that if you put in payments for 300 months of $2,415, you could receive today $413,000. So the signs change because it's taking a different perspective. It's taking it from the other end. But the numerical value is still $413,229. And that's what you still owe. And you could subtract that from the $450 to see how much you paid, which is just under $37,000. That's the basic calculations with home mortgages. Let's look at points and fees, which are a part of a lot of loans. And again, let's look at 3 loans. Points are paid to reduce the rate. Fees are just charges that the bank charges. They may be for a title search, just the paper processing that they do. They have to check your credit rating and all this kind of stuff. I looked at one recently and they charged $3,000. I looked at another one and they were charged about $2,600. And it varies. And one said that they waive the fees oftentimes if the credit rating is good. Now that's unusual. But they are somewhat negotiable, perhaps. The problem is many loan officers do not have the freedom to do this. You may have to work up with someone else or something. Let's look at 3 loans, $250,000 loans. The first one has 0 points. Shouldn't be a dollar sign on that, so we'll do that. 0 points. Points are a percentage of the loan value. The second one has 2 points. 2 points for a 0.5 reduction in the nominal rate. So the nominal rate went from 4.75 down 0.5% to 4.2%. But you have to pay $5,000 in points. 2 points, 2% of $250,000 is $5,000. So that you pay out of your pocket, it's negative. You receive the loan for $250 and pay out $5,000. So essentially your net $245,000 at closing to pay for the house, $5,000 out of your pocket. But you do have to pay that. And the question is, what is the effect on the ultimate rate if that happens? The third loan is fees. No points, and the fees we're going to get to as we go up down here. It'd be $3,000 in fees which you pay. So what we want to do is find out what is the APR monthly for these. APR is used because that includes the cost of fees. It gives you a better idea to compare rates, compare loans, to see what is the actual rate that you're paying. We get that then the same way as before. The payments for each one of these, C36 is the rate, divide by 12, get the PIRs. C38 is the number of months, 360 for all 3. C32 is the loan amount, and it's going to go to a balance of 0 at the end. And you get the 3 payments here for the 3 situations. This payment for this one with the points is based on the original value. The loan is still considered $250,000, although you're paying $5,000, but that just achieves the rate reduction. But the payment there is $1,229.85, and that's because you have a 0.5% less interest rate. So that saved in a monthly payment about $170 or so. The third one, no fees, so it's the same payment as this one here, because there's really no difference at this point. That comes later when you take out the fees. So the fees paid up front, they were zero here. We say that won't always be true. Maybe it should be on all of them, but I wanted to contrast these. $3,000. You have to adjust the loan value for the fees, for the points, and so here you essentially are getting a loan of $245 after you pay the reduction in the points, and here it's $247 after you pay the fees. Then we can recalculate the rate based on this, and on the first one there were no fees and no points, and it comes out the very same thing up here as above, which it should. Just going backwards, the same rate function with the number of periods, the payment, present value, and future value from up here. On this one, we use the new adjusted loan value in D42. Otherwise, the number of periods and the payment takes this payment, $1,229.85. But considering that you really are only getting a loan of $245, it says the rate really is 4.421. Now that's better than the 4.75 if you hadn't paid the $5,000. So overall, you come out ahead by paying that $5,000 up front. It reduced your rate enough so that you come out ahead, and that's why you do it. Over here, the fees, same thing. Use E42 to determine the loan value. Is $247 after we take out the $3,000 in fees. The rate then ends up to be 4.88855, and that's so they quote you a rate, the nominal rate of 4.75, and the banks have to give two rates, the nominal rate and the APR is 4.855. That's why you get two rates oftentimes at banks. I think always at banks. I think that's legal, or a legal requirement now. And that explains what you get with three ways of looking at points and fees, and there's no reason why you couldn't have points and fees. In fact, you often will, and you go through somewhat the same thing, except if you had 3,000 points, this would go down to 242, and then you could recalculate very easily and have what you have here. Finally, let's look at a lease versus buy situation. You often lease cars or buy a car. Companies can lease machinery. Leasing can be used a little bit of anywhere where there's a resale value of the asset that you're purchasing. In this case, we're going to finance $35,000 for a car, either on a lease or we're going to pay $35,000 for it. But the difference is that on a lease, there's a future value. If you buy it, you pay everything. You owe nothing at the end. On a lease, you owe, in this case, we have $20,000. That is the value of the car you're turning in. So you're essentially turn the car in, you're paying them $20,000, the value of the car. We're going to use an NAR with monthly compounding of 7% for lease, 5% for cash. Why is this higher? It isn't always higher, but there's some risk for a dealership or a finance organization, and they don't have control of the car, and what will happen to it there's just a little more risk for them on a lease. What happened to the value of the car? They may think it's going to be worth $20,000 at the end, but the cars turn out to be lemons and are only worth $5,000. Then they're out $15,000. So there's more risk there, so they get a higher rate typically. On the other hand, this prices here are based on the list price for the cars that you see on the window, and the dealerships and so forth don't have to pay that much. And so they don't have quite the $35,000 invested in it that we, the purchaser, would. So it's very confusing a little bit just what these rates are. But this gives you an example. The PIR monthly, divide those by 12. In each case, the future value is $20,000 when you turn the car in. Here it's your car. In fact, you might even say there's a positive value because you still own the car. You could trade it in on another car, or you could sell it, or you could use it for another 10 years or whatever. But we'll say it's 0 because you don't have to pay for that, so you wouldn't want to add it in there. So then you determine the payments like we've been doing right along. The rate is the PIR. The number of months is 36 in both cases, which isn't necessarily true, but we'll do that here for comparison. C49 is the amount financed in each case, and C54 is the balance at the end, or it's 20,000 in this one, and this one in D4 it's 0. And you see the two substantially different payments, $579 for the lease, $1,048 for buying. And there's a lot of different opinions out there as which way is the best way to go. If you can afford it, probably buy is better because you can then trade in and you gradually build up a little equity. The automobiles are certainly not something you depend on to build up equity because they depreciate so fast. You drive off the lot and lose $10,000 or 10% immediately. But that is the lease, how leasing works, and it's true with cars, machines, whatever. And that ends this video segment.